Um, Again, welcome to this learning series, Functional Full Color and Safe 3D Printing for Education. First of all, I'm incredibly happy with you to be with you this afternoon here in Boston area, and for you other parts of the country and the world. It's hard to be quarantined at home. So the fact that I'm going to talk to fellow engineers, educators, we could chat for half an hour. It's incredibly exciting. So we have around 18 to 20 people on the call. Few of you are still joining. So hello, Adrian, Benjamin, Cyprian, Dave, Ed, Karine, Kevin, Laura, Marty, Nicholas, Kaiser, Richard, Thomas, and from RISE we have Dorian, Lachag, Greg Donald. Greg will be helping us. He'll be joining the presentation today. He leads our education initiative at RISE. Jay Salfis and Ross Berger, along with me, Kishore, on the call. So just to introduce myself, I'm Vice President of Products and Marketing here at RISE. And before joining RISE, I was VP of Product Management at SolidWorks for many years. So 3D printing, it has become almost a universal language now. Whether you are an engineer, an artist, an architectural student, whether you are in industrial design, 3D printing is a medium by which you can take your idea and make it a reality in less than 24 hours most of the time, and visualize it in your hand, either at full scale or as a scale model, and innovate on it and make your ideas better. And we at RISE are fully committed to helping you achieve that particular dream. So basically, if I can move to the next slide. So this is a learning series. This is one of 4 or 5 presentations we will be doing, and hopefully you and in the future your colleagues and students can join and give us feedback as to what else we can present to help you advance academia, innovation, and all that good stuff. So this particular presentation is focused on educators and students to create sustainable and inclusive innovation. This is important because additive manufacturing needs to go at scale, and a lot of things we are going to discuss today. I hope you find it valuable and you can share it with your colleagues and students. Today we are going to talk about 3 topics: the value of functional color parts in education. We are going to talk about health and safety. This is a topical subject right now. Health and safety is on the top of our minds, especially with COVID-19 and many things going on. And there's a lot of help all of us can do to make things better, whether it is coming up with a new idea and product for hospitals, for medical staffs, for patients, or whatever that might be. So we'll talk a little bit about health and safety. And if we have some ideas that we could implement at RISE to help really stressed out, emergency care, ER physicians. My brother is one. I was talking to him. He is in Cleveland area, and he is ER. He's in emergency care. He's taking care of patients. Majority of them are coronavirus patients right now, and he tells me, I was talking to him yesterday, it's incredibly hard on the medical professionals now because there are no clear guidelines, and not only that, they don't know what can really help these patients recover other than the fact that giving oxygen. So I think, and they're also short of supplies, really short of supplies. And if there are some brilliant ideas amongst you, feel free to send us those. We will try to design them, print them, and see if we can make a difference to one, few, or many of the people that are battling this particular situation right now. I'm going to talk a little bit about RISE here because this is our augmented polymer deposition. It's the next generation technology. I think I won't spend too much time on it very quickly. The second webinar we are going to do is around smart spaces to drive innovation. Smart spaces are those that you create in your universities, in your offices, where in ideation to design to 3D print is incredibly seamless and fast. And we are working with SolidWorks, with CATIA, with many other companies. And we have some customers that have implemented these smart spaces. I think you will enjoy listening to this and what's happening in the industry and how you can move your department's students forward, creating smart spaces, not just 3D printing isolated on its own, but in a fully connected environment. The other topic, which is the webinar 3, is we're going to talk about leading with material science. Because at the end of the day, where 3D printing struggles is a lot of times the discussion is about the printer. It's not about the user. It's not about the materials, because materials drive applications. And at the end of the day, 3D printing is just a tool. We are using 3D printer to make something, to manufacture something. And so, in fact, we think all of us should lead with material science, lead with what material, why and how, and then think about what is the right printer. So we will discuss this a little bit, the series 3 around leading with material science, and we will combine the first webinar today, the second webinar around smart spaces, the third webinar around leading with material science, and put it all together into applications. What are the keys to success? After this webinar, I'm going to send you an email requesting what are your top 3 applications that you're interested in. And what we could do is take your feedback and incorporate that in the 4th webinar we do, which is around applications. And if there are other ideas that you have, we can build on top of it and move forward as well. So one slide about RIZE. We are a Boston-based startup. We are growth stage. We have many customers that we are incredibly proud of. Merck, for example, is using our unique materials to do some very interesting things. I cannot get into the details of it. ConMed, Virginia Tech, Department of Navy, U.S. Army, PSMI is a large tool crib supporter of around 200 plus manufacturing plants of automotive and such. They are a customer of ZF, Newer and Facades and such. One of the things we are doing at RIZE is our goal is to give you a certified printer with certified materials. And this is important because, listen, in your university or office, you wouldn't put a light bulb that's not UL certified. And we believe for additive manufacturing to go at scale, certification is necessary, quality controls are absolutely necessary. So that's why we have the printer certified and the material certified, and we will talk about that as we move forward. And we are world's first at few things. Obviously, we are proud of it. One is we have our patented augmented polymer deposition, the world's first and only UL 2904, Green Guard certified, and also full color FDM 3D printing platform. So enough of that. So Greg, you want to talk about your favorite customers here?
Yeah, so on this slide, we have a couple of academic institutions that recently added RIZE solutions, and we're citing them just because they are unique in that they're academic institutions, but they're very different in terms of their approaches. So Georgia Piedmont, 2-year technical school in Georgia, previously had lower cost machines, and they decided in the new media program that they wanted color. But they didn't just want color, they needed functional color, and they looked around. And they found out through the grapevine about X-RIZE, and so they were one of our earliest adopters. Wentworth Institute in Boston already had a very well-established fabrication capability, but when they were creating a new additive manufacturing center, they added a wide range of technologies, and they also added RIZE, and they did so because they were really focused on additional capability and some additional capacity. And so, for these institutions, a very different approach, but they liked the messaging, and it was a nice fit within their expanded labs.
Okay. Thanks, Greg. What are the current challenges in FDM? And this is based on customer feedback and what we see in the industry. The first thing is complexity. Complexity in using soluble supports, removing supports in traditional FDM, where once you remove it, you don't have a functional surface. You need to do further smoothening operations or some other post-processing to get the right tolerances. And also the Z strength, because of the way FDM works, you put one layer at a time, and your Z strength is compromised compared to X and Y. Safety. For example, there's a university in Boston area that has banned ABS anywhere on campus because of the toxic fumes that come out of it. We will talk a little bit more. Security. There's a lot of IP in 3D printed parts. How do you make sure that your IP is secure? How do you make sure that it's traceable? And we will talk a little bit more about that. And on the left-hand side, what you see is an extruded filament. It can be FDM, it can be FLA, it can be FLS, it doesn't matter. When you do it, there are a lot of ultrafine particles and gases coming out into the air. And how do you manage that? In fact, one of the questions you might want to think about as we present today is how are you managing your 3D printers on your campus and at your office when you're printing PLA, ABS, and such, okay? So at RIZE, we have two things. One is process innovation, where we combine a material extrusion and ink jetting into one with voxel level controls that create full color functional parts. And also our material science innovation. This is for a little different topic. We will skip that for now, okay? So IDC recently wrote a article about why APD is the next generation. We will skip that. Let's get into the core of what we wanted to present. The first one is value of color parts in education. One of the things you get when you 3D print in color with RIZE is number one, you get vivid color. You can see the shoe. This is a assembly of different parts in different colors, and some of our customers tell us they deliberately print the left side part in one color and the right side part in another color, whether it is knee surgery or whether it is an assembly, because the person who is doing assembly a lot of times on the shop floor it can tend to prone to mistakes, and sometimes the workers are very transient as well. You get new people coming in and out. How do you make sure you create quality on assembly? And here's an example. The red part goes into the green part, and you basically tie it with the yellow part, and that's it. So you don't need to say this is a buckle, this is that, and any of that. So you can do that with RIZE. And in fact, the strength of this part is almost twice as strong as ABS and stronger than polycarbonate and polypropylene. If you're in engineering, you can actually visualize your stresses and everything in full color. And if you are somebody in industrial design, or if you're somebody in the art school, or if you're somebody doing some packaging for some other company or consumer products, you can 3D print your design and within 24 hours have it in hand with accurate colors. Here's an example of a customer where they color coded the part based on deviation between design and manufactured. A lot of times you design something and you manufacture something and your tolerances are off and things like that. They did this to show, you know what, this particular part, this is how it is. And the red means it's not acceptable, blue and green is okay, and such. Your biomedical department, for example, can actually do a 3D printed heart. Just for your information, this is a thing called Living Heart Consortium of several universities, professors, surgeons coming together. And the idea is that before you go to surgery, you can MRI and CAT scan a heart, and then you 3D print that personalized heart. You section print it. You go in and see how the surgery needs to be done. You can improve patient outcomes, combine multiple surgeries into one, and basically have surgeries in shorter times. And this is a story that Dr. Hoganson at Boston Children's Hospitals tell us when they 3D print the personalized heart, right? So basically what RIZE means to you and the value of color parts in education is that not only engineering, but architecture, industrial design, life sciences, art and humanities, business and marketing. All these departments can come together and create amazing innovations. 3D printing, as I told you earlier, is just a tool to take an idea into a physical form. And ideas don't necessarily stop in engineering. Ideas are everywhere. And we are all builders. You go into some of the people, customers I talk to, you see the woodworking they do in their shop and whatever that means. Ideas are everywhere. And how do you take that idea into reality? And not only that, the world is full of color. How do you take that idea into a functional part that is incredibly strong, stronger than ABS, and again, lifelike in full color? And that's the value of getting color into education, is now you can have students with different aptitudes, some good at art, some good at architecture, some good at engineering and STEM, some good at other things, all coming together and creating designs and innovating on top of it. And we see it every day with some of the students and schools we talk to. The nice thing about color is with RISE, you get vivid colors, and there's a reason for it. In fact, we have some service bureaus that have other color 3D printers, and they print it in RISE and they tell us straight out of the printer without any post-processing. The vividness of the color is absolutely top-notch. This is for both engineers and non-engineers. When we designed this technology, we made it such that anyone can use it to get the job done. So once you have a watertight 3D model with colors, going to 3D print, it's fairly straightforward. And so that's how this is designed to make it work. And it's good for schools because every year you get new TAs and new RAs and new students coming in. So the uptime and getting started is very, very small with RISE. New applications. We can only imagine so much today. We go to customers. A lot of times they tell us, what do we do with color? All our parts are either chopped carbon fiber or something like that. With RISE, you can print chopped carbon fiber, but once they start implementing color, some of the very interesting things they are doing, they were surprised themselves. And the way we do color is using CMYK inks. So you get just like, think about a layer, and then we mix the CMYK inks in some color combinations, and we print that color, which is absorbed at the voxel level by the part, and it goes from there. Now let's talk about health and safety. Georgia Institute of Technology and Underwriter Laboratories did an extensive research of 3D printing, and these were their key takeaways. And in fact, this paper is available on UL website. You can get it from the RISE website as well. But here are the key takeaways. More than 90% of the particles emitted by 3D printers are in the nanoparticle range, less than 0.1 micron, and when inhaled can be cardiovascular and pulmonary issues. And the side impact of that is when you inhale it, it's directly going into the bloodstream, and in some cases they have seen changes inside certain things they measured in less than 24 hours. What they also noticed is there are 200 plus volatile organic compounds detected. Many are known irritants and carcinogens. For example, formaldehyde, it's a known carcinogen. Styrene, these are flammable chemical and irritant. Caprolactam, known irritant of eyes, throat, and headaches, and many others. And what's happening today is 3D printing started as industrial, where it is well ventilated, managed by experts to easily affordable, sitting right next to you. But you know what? When you print PLA, ABS, all the common things you're printing, you're getting a lot of these hazardous gases that are coming out of it. They are both short-term effects and long-term effects. When people inhale volatile organic compounds, and there are some health risks that go with it. And this is part of this study that was published. For example, when you print ABS, you get styrene and formaldehyde 100% of the time. And unless you ventilate the printer well, it's not good for students and teachers and users sitting next to it. I have been to some companies that understand this well, and literally every 3D printer they have, except for RISE, they have negative vacuum systems sitting on top of it. So they have a printer, on top of it they have a negative suction system, that's sucking away the gases. Some of them put it in enclosed environments, only you open it a certain amount of time. PLA, formaldehyde, caprolactam, and styrene. Nylon, again, same thing. HIPS, high impact polystyrene, you can see that. PVA, you can see that as well. So my first message to you is if you are using 3D printers, please make sure they are in a well-ventilated room and they are well managed. And number two, with RISE, the way we have engineered our materials is that there are zero VOCs or that come out of the printer during the print process, because the material decomposes at 400 plus degrees Celsius. We extrude at 275. Basically, that's why we got the UL certification, because there are no gases emitting out of the printer. So basically what this means to you is you have 3D printing technology that's incredibly easy to use. So you can actually in less than a day iterate on your ideation to design to 3D print. It's UL Green Guard certified, which means you can be safe knowing that that the students and teachers' health is good. There are no long-term liability issues, and it can sit right next to the engineering process or the design process or in any department for that matter. There is no post-processing. We will talk a little bit more about it. There are zero toxic chemicals. Every part you print is traceable because we actually can print QR codes, part numbers. Students can put their student names that are traceable for any given project or assignment. The material is actually USP Class 6 certified. It's people safe and food safe, and emissions, you have zero emissions. So that is the value of RISE when you think of safety and implementation inside your location. Here's an example. The reason your post-processing is so easy that you are seeing on the left-hand side is we have something called a release ink. So wherever the support touches the part, we jet a little bit of a release ink, and the release ink is like a mold release agent. And the UL certification includes the printer, the material, and all the inks that we have, the RISE 1 release ink and marking inks that we have. So what you see here is you can post-process things really fast compared to traditional processes of, let's say, for example, support removal through, liquids and things like that. Here's another example. This is a fairly large surface. Watch it carefully, how easily it peels off. And the reason for that, again, is this mold release ink in between the support and the part. And you can see on the left-hand side, using all kinds of tools, whereas here, you can see the user very quickly peeling away the supports. Sometimes you do have to use a tool because there are certain areas you cannot reach. Here's another example, fairly large surface. Now the raft is being removed right there. And then after that, you can see how easily the supports come off. And to get to areas that are hard to reach, you just take a plier or something like that, and you can very quickly remove the supports right there. And you have your part in hand. And because of how cleanly the support comes off, the surface that is left after support removal is a functional surface. You don't have to do any post-processing or post-work. The last thing is because we can jet inks as well as extrude the part, you can put a QR code. It's absorbed into the part at the voxel level, which means you can scratch it off. So your IP is secure and fully traceable for the life of the part. You can brand it just like you see right there. So we have some interesting applications. The first one is you can digitally augment the part. So when somebody scans, you can go into your internal systems and fill out the project number. And the project number here could be, here is the student, here is the assignment, this is the date it was printed. And the instructor could actually online take a look at the part and grade it. Or if you are somebody with IP, it's your IP, now you know that it's fully traceable because you cannot scratch it off easily because the ink is absorbed deep into the part. We have people doing some interesting things with SolidWorks e-drawings. You can actually do AR, VR, and MR, mixed reality of the part. So you can scan the part and the full assembly will come, and now you can hide certain components, section it, and now you can visualize the part lifelike with augmented reality, virtual reality. So now you see the part we have created is an intelligent part that's connected with metadata. It's connected with augmented reality and virtual reality and such. Some people do assembly instructions, use QR code and scan the part. You get assembly instructions as to how to put it together. And you can have your internal marketplaces as well. Diverse applications from a single platform, from conceptual design, design iterations. You can put each design iteration number, V1, V2, V3, V4, and now you know precisely which one is what. Simulation, design to manufacturing handoff. You can 3D print parts in color with surface color coding and give it along with a drawing to a manufacturer. Your error rates go down considerably between designed part and manufactured part. Quality inspections with fixtures and jigs, we have customers doing that. Tools, jigs, and fixtures. Not only does the printer print it in white and in color, it also prints chopped carbon fiber, and you can see that as well. End-use parts and the service MRO. Net is it will help drive innovation, compress time to market, and reduce part cost in this all-in-one 3D printer that goes end-to-end from full color to chopped carbon fiber, and in RIZIUM white, which is stronger than ABS and such. So basically what we have is APD systems, RIZIUM, materials, RISE software, and RIZIUM inks. And with that, Greg, I will hand it over to you.
Thank you, Kishore. So
Greg?
I think it's important. Yep. So I think it's important to know where to go if you have any questions. I'm happy to entertain them. Your invitations to today's webinar came from Kishore. You can take down my number or simply send me an email if you have any questions at all. And then, as Kishore mentioned previously, this is going to be a series. Our next webinar, you can look forward to those invitations, will be on April the 9th at 2 p.m. And by all means, we would encourage you, if you have colleagues who you think would appreciate any of this information, please forward the invitation to them as well.
Okay. Let's see if there are any questions, and I will answer those for you. And no matter what, it's an absolute pleasure to be with you this afternoon. It's very hard, I think, to be working alone from home. So it's nice to meet everyone. And again, you can send us an email with questions anytime, and look forward to seeing you. This time we are going to talk about smart spaces. How do you integrate 3D printing into the teaching process that includes the design, that includes art, that includes any number of things, and how do you make it integral such that 3D printing a part with the 3D printer is like writing with a pen. And so just like you jot down your idea on a piece of paper, once you create a good smart space, it just becomes a natural practice to go from ideation to 3D print and back to ideation with design change. That's the next webinar. See you in 2 weeks. Please stay safe. As I said, if you have any ideas, design ideas, or if you have done some designs where we could 3D print, and then help the frontline medical professionals, patients, or anybody, please do send those ideas to us. We are actually working with a couple of hospital systems here in Boston area, but you know what? Not all ideas can be formed between 10-15 people. We need to collectively harness it. Please do send it to us. Look forward to your feedback, and look forward to speaking to you, your colleagues, and your students 2 weeks from now. Have a wonderful day.